Hey everybody, welcome back to my Scorpion Controls YouTube channel. In this part one of a two-part series, I'm going to discuss the Pepperl and Fuchs IO-Link Master Block, the ICE2 IO module. Alright, so looking at the data sheet for the ICE2, looking at pepperlfuchs.com, tells me that the module is an Ethernet IP field bus module that has 8 Type A IO-Link master ports that follow the IO-Link standard version 1.1. The field bus module serves as an interface between the controller of an Ethernet IP field bus system, so a controller like a PLC that's on Ethernet IP field bus, and uses IO-Link devices at the field level. In my example, I'm going to be using an IO-Link Pepperl and Fuchs laser. Alright, so looking at some more of the specs here for the ICE2 master block, looking at the electrical specifications. Typically, the rated operating voltage 20 to 30 volts DC, so your nominal voltage is 24 volts DC. That's the model that I'll be using here. And this has a very low current consumption. So this guy is only going to use about 120 milliamps. It's a very low current consumption device. Looking at the interface. So interface type, this guy is using industrial Ethernet, and it has the M12 decoded ports for your industrial Ethernet. And the transfer rate on these is your typical 10/100 megabits per second. Moving on to the input and outputs. So as far as the ports go, you have 8 IO-Link Class A ports on here that are configurable. So you can configure each port. You could have a maximum of 8 IO-Link and 8 digital inputs. You can configure this as a maximum of 16 digital inputs, so 2 channels per port. Or you can also have a maximum of 8 digital inputs and 8 digital outputs that are short circuit protected. Moving on to the sensor supply, port 1, you can have a maximum of 1.6 amps through that pin 1. Port 3, you can have a maximum of 1 amp on that pin 1. Ports 2 and ports 4 to 8, only a maximum of 500 milliamps per port on port 1. And the output rated operating current per port is a maximum of 200 milliamps. Okay, so now that I covered some of the specs of the ICE2 master block, let's go into how we configure each of these ports as either an IO-Link device, an input, or an output. It's very simple to do. All we need is a web browser, whether it be Chrome, Edge, or Explorer. But let's go through the steps and how we set this up. So in order to go online or dial into the ICE2 block, you need to know the IP address. And the default IP is easily found on the back of the unit. And on mine here, it's 192.168.1.250. Now this unit is configurable by way of the dials on the front or within the GUI, but that's another video. In this video, I'm going to stick with the 192.168.1.250 for accessing the configuration pages. Alright guys, so once you get this set up, you can see the home page here, and you can see that I've typed in the default IP of 192.168.1.250. If you get your hands on one of these and you can't seem to connect to or log into the configuration pages, make sure you check the octals on your laptop or desktop on the Ethernet that you're using. Make sure they match 192.168.1 and make sure that you're not ending with 250 as well. Okay, so once you're all set up and you are logged in, you are brought to this home page of the ICE2 block. Right, so here is just showing you the type, article number, your application base for the Ethernet, and some uptime, and also its supported protocols. In our case, this device does Ethernet IP, Modbus TCP, OPC UA, and MQTT. My intent is not to go through every single tab or submenu that's available, but just kind of cover the basics to show you what is available to you once you log into the configuration files. So first thing I'm going to go to here is my diagnostics. I'm going to click on that, and here you can see the status of each port. So currently right now under port 1, I just have my laser plugged in, the VDM28. This is the laser that I will be using in part 2, where I'm showing you how to bring values into ignition using this ICE2 block or in UPC UA mode. Anyways, this is where you would see what's all plugged in here. Lots of useful information. And if you watch carefully, if I disconnect the laser and I actually plug in an IO-Link RFID tag reader, you'll see this screen update to reflect what's actually plugged into port 1. So it's refreshing, and there we go. Now it sees that it's an IQT1, still Pepperl Fuchs. Doesn't matter what brand, but that's the two devices I had to play with. Right, and so yeah, it will update. It knows exactly what's put into here. Okay. If I go under configuration, well, before I move on, I can just kind of go over this as well. So Ethernet IP. This is where you can. This is more diagnostics about the Ethernet IP itself. There's some Modbus TCP. Again, more information if you need it. UPC UA, which is what I'm going to be showing you in part 2. Currently I have it running, but in part 2 I will start from scratch and I'll show you how to set this up. And you have also MQTT. Alright, so right now that's disabled. I'm not using that. Alright, so configuration. So this is where you actually set the ports as to what they are. So port 1 to 8, right now they're all set to IO-Link, and right now we have in port 1 my RFID tag reader. So if I wanted to change any of this, I can click edit and I can rename these ports to anything I want. Here's where you configure the ports themselves. So port mode, so right now it's under IO-Link, but I can also set that as a digital input or a digital output. So if I just want to use a standard proxy, or say I want to drive a low current device such as a solenoid, as long as you don't exceed the current ratings of that port, you can do that, right? Maybe you want to drive as an output like a little slim relay, like an optical relay, right? That's where you would configure that, and then any other settings that you need to configure based on your what you're doing for that port, you would set these as well. Looking at the configuration here, device validation mode. So mine's set to none, and what that does is allows me to plug in any device into that port that's IO-Link without it saying, hey, this is not what should be in here, so I'm not going to accept this. Right now, port 1 will accept any IO-Link device I put in there without faulting out, and it will just update accordingly. If I hit get attached, it will self-populate all the required information in here, including the length of the inputs and outputs, so 32 bytes each. And we're going to get into the IODD files too, so that will, kind of lay out how the mapping is for the data. If I go back into here and I plug in my laser, plug that back in, so I'm going to unplug my RFID tag reader and just plug the laser back in. Give that a second to kind of refresh. I should be able to say get attached once she's communicating, and it should update with the new values, which I believe it did. Yeah. All right. So that's what that's all there for. If I wanted to set this so that it's a compatible device, meaning, all right, I've changed my field device out. It's not the exact same, but it's very similar, right? I can set it to compatible. If you need the device in port 1 to be exactly the same when it's being swapped out, let's say you have a defective device, you can say identical, and then it checks to make sure that whatever's being plugged into port 1 is identical to what should be in there. All right, so again, it depends on your application, what you need to be. For me, I just put on none because I'm flip-flopping between an RFID tag reader and a laser. All right, but once you set all that up, you just click save, and it keeps that information. Alrighty. So Ethernet IP, this is where you configure Ethernet IP. Let that kind of come in. It's already in there. So lots of information, but again, if you need to change it, just click the edit button based on that port that you're using and make the changes that you need. Same for the Modbus. UPC UA, I believe I have it enabled. Like I said, it is currently enabled. In the part 2 of this series, I will have this disabled, and we will do this from scratch and show you how to get this running in UPC UA. We also have MQTT configuration, which I currently have disabled. I do not have any MQTT devices to use, so I'm not playing around with that one. The network itself, this is where you can set the IP address if you're, obviously you want to change it from the default. So you go on to edit, you get a little warning, and here you can give it a host name. You can, if you want it to be DHCP or static, right? If it's static, you're going to set your static IP address to what you want it to be, your subnet, your gateway, any other information that you need. Hit save, cycle the power, and it will save as what you put in here. For me, I'm going to keep it as the 192.168.1.250. Miscellaneous. Let's see what's under miscellaneous here. Stuff in here. Really not going to get too much in detail. This LED flashing, I don't have another camera to show you, but when I click this, it toggles all the LEDs on the ICE2 block between yellow and red and green. All right, so I guess that's a good way of identifying if you had multiple ICE or multiple IO blocks, which one you're actually connected to. All right, let's see what's in here. So there's stuff in here that we can do as well. Yeah, I'm not going to go through every single one because I'm not fully aware of everything. I haven't played around too much of this stuff in here, but it may be something that's useful for you. All right, advanced. So advanced, again, some more information. I'm not going to get too involved into it, but it's in there if you need to look at it. Attached devices. So attached devices. This is where you're going to upload your IODD files, which is like an EDS file. These files are for the devices that are plugged into the ICE block. So any IO-Link device, you need the IODD file in order for the device mapping. So this knows how to map everything, all the data. And those, you get those from any vendor. So in my case here, if I look up the laser, I can download right from the website. So if I, let's see here, VDM, let's see if it comes up, VDM-8-L1, and let's just see if I can, this is the one I'm using here. So if I go on here, that wasn't the Pepperl and Fuchs website. I want it right from the website. And of course, it's not showing up unless I put the full part number in. So let me do a little shortcut here. Let me just kind of grab this right here. All right? Because I do want to show you where you find these files. Okay. There we go, Pepperl and Fuchs. So if you bought one of these, right, there's the laser I'll be using for part 2. You can go down, and in the case of this manufacturer, to software, right? And you would download this file here. Save it somewhere in your computer where you can find it. And once you have that, you go back to here and you click upload file. You choose where it's at and select upload, and it will populate into here. All right. So that's that. And let's see, so attached devices, port 1. Let's go to port 1 here, because that's where I have something hooked into. This is where it kind of gives you your index numbers. And again, all this is found on data sheets too, and tells you where to index to. So this index is, when you're doing your PLC program, if you want to pull for this information, you would use this index. Now I'm sure it's the same with other manufacturers. Pepperl and Fuchs, they do have AOIs that will work with Rockwell that they've already created, and it will have points where you put the index number in, and then you just set the read bit, and then this will come back. It will fill in the AOI data type. All right, so these are the indexes where you'd pull the information from. I don't need to use this when I'm using an UPC UA for ignition, and I'll show you that in part 2, but I'm able to display this on my HMI screen, very easy. I can also display the distance that's currently at. So right now I'm showing 1 because it's not really pointing at anything, but if I move this laser around so it can see itself, let that refresh, let's see here, there we go, 172. If I keep moving around, so it's a little slow refresh rate on this screen here, but in the actual HMI that I'll show you, it does react very quickly. All right. So a bunch of other information if you ever want to bring this onto an HMI screen for troubleshooting purposes. All you need is the index and the sub-index maybe, and you're good to go. You can grab all this information. Just be aware that some of this is only a read-only, and some is a read-write, where you can write information to it. Okay, so that's the same for all 8 ports. Under the summary here, let's see what it gives you. It just gives you all the ports. Same thing we're kind of looking at, right? So all good, and then you got a support screen if you need help with it. A little overview here, right? Some help files. So again, I hope that helps you out. I'm going to leave links in this video if you want to visit this page. I'll leave a link in the video. I hope you found it useful, and I hope you come back for part 2, where I am going to show you how to put this into UPC UA mode and pump data into ignition. Until then, cheers.